Hello, everyone. Good evening and welcome to Alumni University. I'm Kristen. I am the Director of Constituent Engagement here at Illinois Tech. Behind the scenes is Joe Volan as well. Before we get started, just a couple of housekeeping notes. We are in a webinar format, so you can see the presenters, they cannot see you. If you have any questions for Ken during our presentation, if you could please type them in the chat box at the bottom of your screen, we will be sure to get them answered after Ken concludes his presentation. Also, please note that your viewing experience could be affected by your internet connection. So if you're having connectivity issues, we recommend restarting Zoom and reloading your Wi-Fi. Just so everyone is aware, this presentation is being recorded. It will be available in the next couple of weeks at iit.edu/alumni university. So now I'm so happy to introduce our presenter. Ken Christensen joined Illinois Tech in November of 2020. He is the Carol and Ed Kaplan Dean of the Armour College of Engineering. He also holds a joint appointment in the Department of Mechanical, Materials and Aerospace Engineering and the Department of Civil, Architectural, and Environmental Engineering. Ken joined us from the University of Notre Dame, where he was the Viola D. Hank Professor and Chair of the Department of Aerospace and Mechanical Engineering, with a joint appointment in the Department of Civil and Environmental Engineering and Earth Sciences. Ken has served as the Assistant Dean for Faculty Development and a Provost Fellow while at Notre Dame. He was active in college and university level initiatives focused on cultivating industry partnerships to enhance educational and research opportunities. Prior to Notre Dame, Ken spent more than 15 years as a doctoral student and then a faculty member at the University of Illinois at Urbana-Champaign. He has a BS in Mechanical Engineering from the University of New Mexico, an MS in Mechanical Engineering from Caltech, and a doctorate in Theoretical and Applied Mechanics from the University of Illinois. His research interests include experimental fluid mechanics with an emphasis on flows central to a range of energy, environmental, and geophysical applications. So with that, I will turn it over to Ken.
Thanks very much, Kristen. All right. So thank you very much for the kind introduction. And it's a pleasure to be here with all of you. As Kristen said, I've been at Illinois Tech for 4.5 short months. Although I've enjoyed it very, very much. It's been a short period of time to learn a lot about the institution, about the people, and also about those of you that are alums. And I see many names on the participant list that I recognize, and I see others that are new to me. And so I look forward to getting to know most of you more, and to also talk to you today, both about me, an introduction of who I am, what my interests are, but I also want to give you a bird's eye view of Armour College and its activities. And then I'll close my presentation by talking about some opportunities and new initiatives that I think will help Armour College reach its next level of preeminence and impact. So a little bit about me. And Kristen gave you kind of my academic background, so I'll go through this quickly, but I was born and raised in Santa Fe, New Mexico. I played sports as a child. Baseball and tennis were my primary sports, but I was also a science fair nerd. And through junior high and high school, that's really where the bug bit me in terms of pursuing research and kind of that curiosity to explore new areas of knowledge. And in fact, I was an intern at Los Alamos National Lab in high school. And that, again, gave me my first taste of formal research. And so that is basically where my path in research and academia started. Both of my parents were teachers. My mom, an elementary school teacher, my father, a high school teacher, my sister is a middle school teacher. So the teaching aspect of being a faculty member in academia is really born out of my own family. So as Kristen mentioned, I did my bachelor's degree in mechanical engineering at the University of New Mexico. I then went to Pasadena and did a master's degree at Caltech. And then in 1996, I moved to the Midwest. And actually, I've been in the Midwest ever since then, except for 2 years, and I'll explain that in a moment. So I'm a Midwest transplant, and I really love being here. I love the culture. I love the area, although I do miss the mountains and the food of New Mexico. But I've been welcomed with open arms ever since I arrived in Urbana in about 25 years ago. And like I said, I've stayed ever since. When I finished my PhD at the U of I took an assistant professor position at the University of New Mexico. And then in '04, I returned to Urbana as a faculty member this time. And I was there for 10 plus years, assistant, associate, full professor. And then I served as associate department head in mechanical engineering for a couple of years before I joined Notre Dame, which is where I was before I came to Illinois Tech. And in fact, our current provost at Illinois Tech, Peter Kilpatrick, was the dean of engineering at Notre Dame at the time, and he recruited me to Notre Dame. And so I've known Peter for 6+ years of my academic career. As Kristen mentioned, I had a variety of roles at Notre Dame, but most recently was department chair of Aerospace and Mechanical Engineering. So that gives you a little background on me and my pathway. Let me talk for a few minutes about my research interests. So by training, I'm an experimental fluid mechanics person. I study the flow of air and water in a variety of different types of applications. Primarily study flows that are called turbulent flows. Turbulent flows are ones that are at high speeds and can be very complex and time dependent. You know about turbulence when you fly in airplanes and you fly over a low pressure patch and the plane drops a bit or rises a bit over high pressure areas. And turbulence exists in a variety of venues, in nature in particular. And a lot of my work has to do with the flow of air and water in natural environments. I'm going to show you a couple of examples in a minute, but all of it is really based around a unique flow facility that you see here in the lower right. You may be familiar with wind tunnels or water tunnels. This is an expensive water tunnel in that it runs a salt solution liquid. And the reason that we do that is because the optical refractive index of models of some kind of physical system that we'd like to test, if we build that in acrylic, the optical refractive index matches that of this liquid, and suddenly those objects disappear. So let me give you an example of this. One thing we've worked on for many years are what are called Barkhan dunes. And so you can see examples of these. These are these crescent-shaped dunes that occur in desert environments. They often occur in a multitude of sizes and shapes. When they come close together, they interact and they stop having a very symmetric form and they start to deform. These exist on the surface of the earth. They exist in rivers. So this is the Wabash River in the state of Illinois. And you can see these on a centimeter scale level at the bottom of the river. In the atmosphere on Earth, in the desert environments, these are kilometer long, tens of meters tall. They even exist on Mars. And so they're ubiquitous to any sort of sandy environment that's subject to winds, prevailing winds. So what we do is we take models of these dunes. You can see here a CAD model. We 3D print that. We create a negative or a mold, and then we cast a clear urethane, an acrylic, to create this transparent model. Now it's not transparent here in the air because the refractive index of the model and the air are different. But as soon as you take this model and you immerse it in this sodium iodide salt solution, it disappears. So you can see the grid behind here. What this gets us is we're able to use laser-based measurements to measure the flow around these models. So an example of that is here. Here we have a small dune upstream of a large dune. The flow from the small dune interacts with the large dune. This is what causes them to deform in the ways that you see here on the left. So that's one example of work we do. Another project we have going on right now is to study the flow in and around Martian craters. The idea being is that the sediment patterns and the evolution of this topography that you see here in the upper right, this is Gale crater on Mars. It contains historical elements of trying to understand what the physical environment was like on Mars millions of years ago, including whether there was water. So we've studied flowing around this crater by taking a digitized model of this and creating a transparent version of it that we test in our water tunnel. And again, here's a great example of this invisibility of the model in the salt solution. Below this dashed red line, there's the salt solution with the model immersed. And you can see right through it. You can see the grid pattern that's behind it to sort of illustrate this concept. Above the red line, the model's just sitting out in air. And because the optical refractive index doesn't match, you can't see through it. This allows us to look at the flow within the inside of the crater and try to understand, for example, why a crater like Gale has this mound that has formed in the center of it. Okay? And there's many craters on Mars that have this mound. There's many that don't, and so we're trying to understand why that might be, and then also try to put together a history of the way that the surface of Mars has been sculpted by the winds using these kinds of measurements. All right, so now let me transition to talking about Armour College, and I'm going to share a little bit with you about why I took this unique role as the Carol and Ed Kaplan Dean of the Armour College of Engineering at Illinois Tech. But let me tell you just a little bit of a snapshot of the college right now, and then I'm going to spend some time giving you some highlights of our academic activities going on right now, our research activities going on. And that's one way that I want to illustrate to you what excites me about being the Dean of the Armour College of Engineering. So just a quick at a glance here, we have 9 accredited undergraduate programs. We have 11 undergraduate majors and 29 what we call coterminal degree programs. Coterminal degrees mean that a student can enroll in both a BS or an MS or a BS and a professional master's program and complete that pair of degrees within a 5-year period. We have tens of professional master's degree programs. I'll talk about some of the newer ones in a little bit, and we have 9 PhD degree programs. All of these are offered in our 5 departments: Biomedical Engineering, Chemical and Biological Engineering, Civil, Architectural, and Environmental Engineering, Electrical and Computer Engineering, and Mechanical Materials and Aerospace Engineering. So annually, we award 650 plus degrees. We have a student body of over 2,100 undergraduate and graduate students. The split's about 2/3 undergrad, 1/3 grad. We have nearly 100 faculty members in the 5 departments that I mentioned. Armour has a long lineage of excellence in both its faculty ranks and its alumni ranks. For 41 Armour faculty and alumni are members of the National Academy of Engineering. And individuals that have graduated and faculty that we've had at in the Armour College have gone on to innovate wonderfully for humanity. So for example, the father of the cell phone, Marty Cooper, who perhaps has joined us here today, is a electrical engineering grad from Armour College. Marvin Camrus is also an electrical engineering grad, and he's well known for innovations in magnetic recording technology. You might know about the Camrus Scholars Program, that is a very competitive undergraduate scholarship program for students entering Illinois Tech. And Ed Kaplan, who with his colleague Gary Kless formed the company Zebra Technologies in the late 1960s. That company put forth revolutionary barcode printing technology that transformed how barcodes are printed on everything that we see today. And so special shout out here to Ed, who's joined us. Ed, I'll talk about him a little bit later again when I talk about the Kaplan Institute on campus, but I just wanted to say, Ed, I'm really proud to hold the title of the Carol and Ed Kaplan Armour Dean of Engineering, and we're proud to have you as an alum, as we are all of you that have gone on to do great things in your careers. One thing that really drew me to Illinois Tech is it is home to a talented and distinctive student body. In my 4 short months, I've really come to appreciate how hardworking, accomplishment-oriented, multicultural, upwardly mobile, creative our students are. And many of them are first-generation students. And I would say, again, that's something that resonated with me from a professional standpoint. Being associated with the university, that makes that a priority in providing an education to populations of students that might not otherwise have that. So a quick snapshot of our enrollments. Again, we have about 1,300 undergraduate students. They're divided amongst our 5 departments, with MMAE being the largest. At the graduate level, we have almost 600 graduate students, again, distributed amongst our departments. In this case, the ECE department right now has the largest enrollments. Now, let me talk just for a few minutes about what are currently very distinctive elements of an Armour College education. And again, these are wonderful examples of why I'm so proud to have joined Illinois Tech as the Dean of the Armour College, because I really do think there are some very distinctive and unique things that we do to train our students that we should be proud of. So many of you are probably familiar with the iPros program. I became aware of this as I was going through the interview process for this position. It joins students from various majors to work together to solve real-world problems. And often these are on behalf of sponsor companies and nonprofits. And so the idea that business students and law students and engineers and computer scientists and students in the Institute for Design come together to tackle an interdisciplinary problem, that's the kind of training that positions our students for success in their future careers. So in this modality of learning, iPros really do teach leadership, creativity, teamwork, design thinking, and project management, all of the soft skills that are really critical to being successful in today's global workforce. So I'll talk for a moment about that. We also have the Engineering Themes program, which helps students align activities that help them tailor their own learning activities within Armour College. We have the Armour R&D program, which really is a way to get undergraduate students deeply involved in the research activity that our graduate students and our faculty are pursuing. We have a range of student clubs and organizations. You probably were members of many of these when you were a student here. And then I'm going to highlight at the end growing programs that we have related to innovation and entrepreneurship. And all of these are really built around the Kaplan Institute. So as far as iPros go, I just wanted to give you a few examples of those that are going on now to help illustrate the kinds of activities that our students are pursuing. So this example is electric vehicle design for on-road and space applications. And so this actually involves students that work in interdisciplinary teams focused on 2 international student competitions. The Formula Electric SAE race car, okay, that is shown here on the right. And that team builds a car every year, and that car competes in a variety of different categories against many, many other engineering schools. And here on the left, we have the NASA robotics mining competition. And they're basically building a small rover for mining applications on Mars. And this is NASA sponsored. And so through this iPro, these students, again, learn leadership, teamwork, project management, communication skills, and the like. And then they go on to compete very successfully, I might add, in these international competitions. And what I love about these 2 teams is that while at face value, their activities are very engineering centric, there are so many ways to contribute to these activities for a variety of students on our campus that every Illinois Tech College is represented on both of these teams. A second iPro example, and of one of our clubs here on campus, is for the Illinois Tech Railroad Club. It's a model railroad club that actually is quite thriving in the CAEE department. And so these students in the fall of 2019 in this example chose to design and build a functioning locomotive cab simulator. Okay? And this was in collaboration with the Northern Indiana Commuter Transportation District that operates the South Shore Line Railroad. And it involves students from both Armour and the new College of Computing. So I mentioned earlier the notion of engineering themes. And this is really a pillar of Armour's distinctive education initiative. And it allows students to explore global contemporary challenges and work towards developing solutions of societal impact while pursuing their undergraduate degree. There's 4 themes right now for the engineering themes program: water, health, energy, and security. 4 critical grand challenges that are impacting humanity. What's interesting about this program is it allows students to stack experiences. So small pieces of experience that they might get through their tech electives, iPros, other engineering projects, internships, lectures and panel discussions, fieldwork, design projects, networking opportunities. And it really allows them to customize their education while they're enrolled at Illinois Tech. And really the result is an individualized engineering portfolio of experiences, and most importantly, an individualized educational experience that they're leaving Illinois Tech with, that they're armed with to do great things when they take their first job. The Armour Research and Development Program. Again, unique hands-on experience with research and development for undergraduate students in Armour College. This program actually funds students to do research in faculty labs. They submit a proposal to the college, and we provide modest funding to help support their activities. And each year we hold what's called the Armour R&D Expo, and it allows them to showcase their work. And typically this is a large poster competition that's held, but we had to do this virtually this last year because of COVID circumstances. And so we had a virtual poster session. Here's an example of one of an MMAE student. And we also had virtual presentations given on these Armour R&D projects. I think another really unique aspect of an Armour education is the opportunity to get involved with these student clubs. So I already mentioned a couple of these: the SAE team, the Scarlet Space Hawks, who are building the Mars rover, the Illinois Tech Railroad Club. All of these activities enrich a student's education while they're enrolled in one of our engineering programs, and in many ways complement beautifully the technical aspects of their education with the ability to build those soft skills that make them very competitive on the job market when they finish their degrees. We have a range of student organizations that again provide more opportunities for students to cultivate their leadership and teamwork activities. Many of these are disciplinary clubs like AAA, AICHE, and many of them are involved in doing good work for humanity. So for example, Engineers for a Sustainable World, okay, or Engineers Without Borders. And so these are, again, wonderful opportunities for our students to do things outside the classroom that allow them to leverage what they're learning in the classroom to do good for humanity. You know, in addition to what I've already shown you here, there are also other activities going on that really do highlight novel experiential learning activities for our students. So for example, here, Professor Dave Williams in MMAE has a team of students that are designing a tailless aircraft for active flow control research. And the students were funded by an Illinois NASA space grant. The team of students, which I think is great, involves undergraduates and graduate students. So there's a Ph.D. student that's actually involved in this activity. It's in collaboration with the U.S. Air Force Academy. And what's wonderful about this is that it's not just a theoretical study, but they've actually built a prototype of the system and they're going to be testing this at the Air Force Academy here in spring. I see a question in the chat about, is there a way that alumni can be involved or volunteer with iPros projects in Armour? And the simple answer to that is absolutely. And if you'd like to get involved with that, drop me an email and I will connect you with our academic director and our executive director of the Kaplan Institute, where the iPros are being managed. Okay, with all of these educational activities and co-curricular activities that I've described, I also want to highlight the broad range of career pathways that our students are able to take. So Armour students are placed in traditional engineering environments, in startup environments, and a broad range of other potential career pathways. So Boeing and Northrop Grumman and Sargent and Lundy, Gecko Robotics and Whirlpool and Exelon. We typically have between 85 and 90% of our graduates placed 6 months out of graduation. And we're the #2 university in the nation for overall upward mobility, #1 in Illinois for lifting students from families in the bottom 20% of income to the top 20%. So this really aligns with the mission of the university to provide an educational experience for students that might not have otherwise had that opportunity. And we're the #39 best value national university based on US News and World Report. And many of you might be wondering how we've handled things in the last year with the onset of COVID and the need to move to remote learning environments. And in engineering, this is challenging because a key aspect of an engineering education is hands-on learning in laboratories and design classes and the like. And the other comment that I'll make is the shift to remote instruction in March really disproportionately challenged institutions like Illinois Tech that are dedicated to a personalized educational experience. We're small for a reason, because we want to tailor the educational experiences for our students in an individualized way. And it's really hard to do that in a remote environment. So we've worked hard to overcome that. Some classes were still held in person. So here, for example, is the introduction to the profession course in the BME department here in the upper right. We've had faculty be very innovative in the way that they've engaged with students in a remote environment. So here's an example of Harry Smith, who's a faculty member in the MMAE department. I'm going to play a little bit of this video to give you a flavor of how well we've become in engaging with our students in a remote environment.
To understand the changes that you make to the airframe, how they affect the aircraft range, which we define as how far it can fly, and also the aircraft endurance, which is a measure of how long. One thing that I have not told you in this question, because I'm sort of going through a question and showing you how to do it, we're going to... So we produced this script last week that helped us to plot different aerofoils. So this one here, let's move that arrow down a bit. This one.
So we've learned how to leverage technology in unique ways. And while COVID has really challenged us both personally and professionally, and it's been very difficult for all of us, we can take away some positives in that we've learned how to use technology in new ways to help our students be more successful in their learning. And we plan to carry those forward in the way that we engage with our students, even though we'll return to a predominantly in-person modality in fall. So now I'd like to move on and talk a little bit about graduate education and research. As I said before, we have dozens of master's programs. Many of the most recent ones are directly targeted at emerging workforce needs. So for example, in the BME department, a new master's program that just came online in biomedical data science and modeling. In the chemical engineering department, a pharmaceutical engineering master's degree. We're looking for ways to engage directly with the pharmaceutical industry in the greater Chicago area to become a partner with them in helping train their workforce. In civil engineering, engineering management master's degree. In the ECE department, cybersecurity engineering. And in MMAE, a recently developed program in autonomous systems. Okay. And so we're really trying to target our academic programs to meet the needs of the technological workforce of tomorrow. On the research side, research by PhD students and faculty is advancing fundamental discovery and yielding technological solutions to societal challenges. There are four main areas that we as a college and the universities identified in focusing our research efforts, and they're all built around the grand challenges that society is facing: autonomy, computations and data, health and wellness, and urban futures. So I thought I'd give you a flavor of some of the activities going on in these areas. In the area of autonomy, here on the left, you see on the top an experimental demonstration of a soft robot that Matt Spenko's lab has built. And on the bottom is a numerical simulation of another faculty member, Ankit Srinivastava, in MMAE, of the same system. The idea here is to build robotic systems that respond to their environment, and in this case, morph to the shapes that they encounter. On the right here, I'm going to play a video of a multimode locomotive robot. Now, this can both fly and roll on the ground over a variety of terrains.
The high-tech robot is capable of both terrestrial and aerial locomotion. The robot is composed of a cylindrical cage connected to a quadrotor through two revolute joints. Thus, the cage can roll freely with respect to the quadrotor body. The flexible structure of the cage, fabricated out of polycarbonate and carbon fiber, makes the robot crash resistant. This simple but arguably elegant design allows a robot to use the same actuators for both forms of locomotion. This keeps the system mass low since the robot does not need to carry the added mass of unused actuators or control electronics. Terrestrial locomotion is successfully achieved over different terrain types in indoor and outdoor environments, even when wind gusts prohibit successful aerial locomotion. During terrestrial locomotion, the robot only needs to overcome rolling resistance. Therefore, it is much more energy efficient compared to an aerial-only quadrotor. This greatly extends the system's operation time and range. On the other hand, the robot's aerial locomotion capabilities make negotiating obstacles extremely easy. The robot simply flies over them.
So those were examples of research in the field of autonomy. Our former dean, Natasha DePaula, who's a faculty member in the BME department, recently established a new research center on campus, the Illinois Tech Digital Medical Engineering and Technology Research and Education Center. The idea here is to forge a digital transformation of medical engineering research. Okay? So the mission of this center is to develop new technologies and solutions for diagnosis, treatment, and management of human disease while preparing a workforce that's knowledgeable in these areas. This particular endeavor combines the priorities of the university in health and wellness and in computations and data. So I'm going to play a short video on this center.
Welcome to a virtual tour of the 3D Experience Learning Lab and Illinois Digital Medical Engineering and Technology, IDMET, Research Center, located on the campus of Illinois Tech in Chicago, Illinois, in the United States. We are currently working on simulations that will take us in virtual reality journeys inside the human body, traveling through the circulatory system into the heart, simulating implant procedures, visualizing molecular structures for the design of new therapeutic drugs, and more. Here we see a 3D holographic display of the heart, providing an immersive experience that enhances student learning. We use 3D Experience for computational modeling and simulation, supporting research projects in medical engineering. A team of students used 3D Experience to model the adhesion of a single COVID-19 virus particle on the epithelial surface of a human lung. In the next steps, we will simulate the combined fluid and mass transport phenomena in the airways during respiration. This will allow us to explore pathological scenarios including respiratory diseases like COVID-19, one of the research projects being conducted.
So it gives you some idea of the use of digital tools to really explore new elements of personalized medicine. So also in the area of health and wellness, one of our faculty members in the CAEE department, Brent Stevens, who's also the department chair, is an expert in environmental processes, and in particular issues of airflow and the like. And he was involved in a couple of very important collaborations related to COVID transmission. So he and colleagues developed a computational model of the Diamond Princess cruise ship, where there was a huge COVID outbreak. And what they were able to show is that the predominant mode of infection was from aerosol rather than droplets. And in fact, they were one of the first studies like this to show that, to really emphasize the importance of aerosol transmission related to COVID. As a follow-up to that, Brent's been working with a variety of agencies to really test air cleaners, particularly for fighting COVID-19. And so they've developed a set of tools that allow them to do testing on a variety of air filters that are available on the market from the perspective of their fidelity in being able to contain the droplets that can and the aerosols that can transmit COVID-19. In the area of sustainability, we're very lucky to have the Wenger Institute for Sustainable Energy Research here on campus. Hamid Arastapur of the CBE department is the director of this, and WISER, as it's called, really serves as an umbrella representation to promote education, research, and outreach related to energy and sustainability. Some of the areas that they work in, the electrical grid and sustainable energy integration. A key part of this thrust is the Galvin Center for Electricity Innovation. I'll talk about that in a moment. There's also a focus on climate change and fundamental research in sustainable energy systems. And then also in the area of sustainable development. And so the built environment and urban agriculture, for example. Wanted to highlight for a moment the Galvin Center for Electricity Innovation. This is directed by Professor Mohammed Shahidapur in the ECE department. And we're really proud that IIT was the first operational campus in the world to have its own microgrid. And this continues today. It's a well-connected grid on campus. All of our streetlights have been converted to LEDs. They're all controllable individually. And so we're really proud of the architecture that's been put in place through the Galvin Center and Professor Shahidapur's and his collaborators' efforts to really make Illinois Tech a leader in the world in this particular area. So I'm going to end just by giving you a few highlights of activities that are going on within the individual departments, and I want to make sure we leave time for conversation here at the end. So Biomedical Engineering is our newest department. It formed in the early 2000s, and right now it has on the order of about 200 students, most of them undergraduate students, but a growing graduate population. We have 14 faculty in this department. BME really is focused on developing new technologies and quantitative methods that advance medicine and clinical practice. So there's a couple of thrusts here. Prosthetics and medical devices is an area of growth and strength for us in our BME department, and also computational biomedicine. I showed you earlier the IDMET center that was just established. This is another example of a simulation that was done in that simulation environment. Here you have a living heart human model, and what you can see here is the insertion of a pacemaker lead. Okay, and so again, having information about the structure of the heart for an individual patient would allow simulations that would be individualized for that person. In chemical engineering, we have a range of activities going on. The focus right now is really on broadening participation of industry and foundations in research programs. And so they've really tried to emphasize building both research and education connections with local and regional companies in the area. It's also focusing on larger research center proposals And I think most importantly, expanding their research programs to new areas, things like pharmaceutical engineering, which I mentioned earlier, food science and technology, and process development. In terms of outreach, we were really happy to celebrate this past February Charles Pierce, who was the first chemical engineering undergraduate degree recipient of African American descent in the US. And this was highlighted last month by the American Institute of Chemical Engineering. Richard McGuire is also a graduate. And for those of you that live in Chicago, he opened the Seaway furniture store on the South Side. And this was highlighted recently by NBC News. And the department was very proud to host the Midwest Regional AICHE annual meeting on campus in 2020. In terms of student experience in chemical engineering, they've really tried to strengthen the AICHE student chapter. We're very proud that it received the Outstanding Student Chapter Award nationally the last 2 years. And we've been doing some renovations to help improve the study spaces for our students. They inaugurated a new student reading room with seating and computers and textbooks. And we thank a generous alum for being able to do that. In civil engineering, we've had several recent young faculty hires, and they've really hit the ground running in establishing their research program. So Matt Gambetta is an expert in precast concrete, and he was just awarded $1 million grant to pursue his research. We just received a $17 million in-kind software contribution from the Trimble Corporation for the Trimble Technology Lab, which will enhance both undergraduate and graduate education experiences in the department. Our students have won many awards. So I was really impressed with this one here on the left, where 5 of the 12 ASCE Illinois section scholarships were awarded to Illinois Tech students. And to put that in context, the ASCE Illinois section includes University of Illinois, Urbana, UIC, Northwestern, so some really top schools. And we won nearly half of those scholarships with Illinois Tech students. And the students in CAE and in architecture have come together to compete in the Department of Energy Solar Decathlon Design Challenge. And they came away with first place in the office building division. And Eduarda Karate is a lecturer in the CAE department, and she's the faculty lead for this competition. So we're very proud of that group. In electrical engineering, we have a technology-rich history in ECE. Lee DeForest and inventing the vacuum tubes. I mentioned earlier, Marvin Kamras, the father of magnetic recording, Marty Cooper, the father of the cell phone, and Rohit Prasad, who is vice president and head scientist of Alexa Artificial Intelligence at Amazon. ECE research really spans a number of areas, from energy and power systems. I talked earlier about the Galvin Center, wireless networking and communications, signal and image processing. We have a medical imaging research center that involves faculty from both the ECE department and the BME department. We have intelligent systems and embedded computing. This is where cybersecurity and artificial intelligence, 2 incredibly important domains for impact on humanity. And we have expertise in those areas, as well as microelectronics and computing systems. Just like we do with Armour R&D, ECE has its own research day, student research competition involving Ph.D., master's, and undergraduate students. We weren't able to hold it last year in 2020 because of COVID circumstances, but we look forward to hosting it again in 2022. And finally, I just want to highlight the MMAE department. We have award-winning faculty there. Many have won teaching awards recently. In the ME program, it's a distinctive curriculum. Design spans from the freshman year through the senior year, and it has a backbone that extends over that entire range. The AE program, very strong experiential design and laboratory activities. And the material science program has 100% undergraduate placement at graduation. I showed you the research of Professor Ankit Srivastava earlier on these numerical simulations of soft robots. Assistant Professor Wei Chen received an NSF Career Award recently. And one of our newest hires, Assistant Professor Amir Mustafi, won an NSF Research Experiences for Undergraduate Site Award. And so he'll be hosting a summer program for undergraduate students interested in manufacturing research to come to Illinois Tech and pursue those activities over the summer under his guidance. And the MME department really does reflect, I think, a very important aspect of Armour's mission, and one that I'm dedicated to growing. And that has to do with collaborations with the greater Chicago area, particularly industries and organizations that reside in the area. So for example, we have an ongoing collaboration with DMG Mori in the area of manufacturing. They donated an SLM printing machine to us for additive manufacturing purposes. We've developed a new master's degree in advanced manufacturing in collaboration with them. And right now, the department and myself are working with the College of Computing to develop an integrated data-driven digital manufacturing degree program that's focused on digital twinning activities. We're also very active in collaborating with Argonne National Lab in research and the Gas Technology Institute. So those are two examples of research organizations in the greater Chicago area that we've forged partnerships with that are very productive for our faculty and also for our students. So I have two more slides and then I'll finish and happy to answer questions. I wanted to talk just for a minute about opportunities and new initiatives. I mentioned early on that there's a growing base of activity on campus around innovation and entrepreneurship. And really the driver behind this is the Kaplan Institute for Innovation and Tech Entrepreneurship, that the Kaplan family generously donated funds to help establish at Illinois Tech. This organization is led by a recent new hire as executive director, Miriam Saleh. And she and the academic director, Mahesh Krishnamurthy, who's an Armour faculty member, are really working to support student and faculty innovators and entrepreneurs. There's an idea shop, which is a rapid prototyping lab within the Kaplan Institute that many of our students use both for their coursework and for their extracurricular activities. And it has a full-time staff. It's really a wonderful resource that we have for fabrication on campus. My goal is to ensure a very strong connectivity between Armour College and its students and faculty and the Kaplan Institute. Because I think together we can really accomplish some wonderful things in the area of building a culture of innovation and entrepreneurship within the Armour College of Engineering. So I look forward to working with Miriam and Mahesh and also Ed Kaplan and his vision in trying to accomplish that goal. A second area of opportunity that I think is really ripe for us is partnering with the new Illinois Tech College of Computing. So you may know that this college was just established this last year with a very specific charge: infuse computing and data science education, research, tools, and ideas into nearly every discipline, course, and activity across campus. So the idea is for this to be a horizontal college such that it feeds knowledge and activities up into essentially every academic program that we have, both on the education side and on the research side. For those of us in Armour, this is a wonderful opportunity because there are several Armour faculty that work in the area of predictive science, using computations to predict physical phenomena, and being able to collaborate with the College of Computing and the development of new algorithms and speeding up technologies and the like to help make predictive science a much more robust and agile tool for predicting a variety of phenomena, I think will really help both our educational and our research activities. I mentioned earlier, we're already collaborating with them on a digital manufacturing degree program that leverages their strengths in data science and our strengths in physical manufacturing. I also think an area that we need to reemphasize in is developing holistic industry partnerships that bring practical engineering systems and approaches to our curricula, and I'll add to our research. So the IDMET center that I mentioned earlier has brought a new software platform from Dassault Systems to bear for our students and for our faculty to use. The Trimble Technology Lab, the donation of software from Trimble, has brought that to our civil, architectural, and environmental engineering students. My goal for Armour is to become an indispensable partner to the city of Chicago in a variety of ways, through collaboration with industry, through partnerships with community organizations, community colleges to provide transfer pathways for students into Armour College to pursue an engineering degree, and with the city and the state, so that we can, for example, contribute to enhancing the infrastructure of the greater Chicago area. And to me, those are the ways that we become that indispensable partner to our region and really kind of fulfill our mission and desire to have that kind of impact. I also think we need to align our degree programs with workforce needs. And in particular, do this in ways that leverage the interdisciplinary strengths that we have on campus. Law school, business school, Institute of Design, New College of Computing, and the like. We need to find ways to take all of our strengths in those areas and build degree programs that can have impact. So in design and innovation, in advanced and digital manufacturing, in predictive science, right? Computing with a purpose, and in stackable programs where a student can take a little bit in the Stewart School of Business, a little bit in the Institute for Design, a little bit in engineering, and a little bit in computing to individualize a degree program that fits their needs for their career. To really realize this vision, we have to modernize our labs and our research facilities. And we really also have to continue to explore ways of supporting our students' success. That's from the perspectives of accessibility, equity, and inclusivity, and in making sure that what we're offering our students and our faculty is really, truly excellent in everything that we do. So with that, I'm going to stop sharing my screen, and I would be pleased to answer questions.
Well, thank you so much, Ken. That was wonderful. Just a reminder for everyone, if you have any questions, please type them in the chat box at the bottom. We have a few minutes left for questions. So we got one earlier. You talked a little bit about this, but if you wanted to expand, we received a question. Are there any Armour projects that work cooperatively in the community or with other organizations or schools in the Chicagoland area?
Yeah, there are many. So for example, we have several agreements with local community colleges, Wright College, for example, and the city colleges of Chicago, to help cultivate pathways for students to transfer very seamlessly into our degree programs from the community college of education. We have a similar program with the College of DuPage in that way. We also have many of our faculty that are reaching out to schools in the area. So I didn't have time to talk about it here today, but one of our BME assistant professors, Marcella Vajcik, taught a course on biomedical transport processes in the fall, I think it was. And one of the culminating projects that she had the students do was to develop short videos explaining a particular digestive process to students at different ages. So one aimed at kindergarten students, another aimed at 5th graders, another aimed at 8th graders. And they shared these with one of the Chicago public schools. I forget which one it was. It's one very close to the Illinois Tech campus. And in this way, we're trying to bridge and outreach, not only with our faculty, but with our students who are really passionate about helping cultivate the next generation of STEM students and trying to excite young people and kids to explore the opportunities that a STEM education provides from a career perspective. So yes, we're very active in doing that, but frankly, we should be doing more of that. And we should be doing more of it within our neighborhood and very close by to really trying to have a tangible connection and impact with the Bronzeville community.
That's great, thank you. And we received another question a little bit earlier in your presentation. Do you see a version of virtual or a hybrid version of learning continuing in the future when classes resume on campus?
Yeah, so that's an interesting question. Let me tackle it from a couple of different perspectives. I think for our on-campus students, we're looking at a predominantly in-person modality again. And in engineering, that's really important because a lot of it is built around hands-on activities in design and labs and the like. I do see a technology enhanced education for those students. So I think, you know, the use of the kinds of technologies I showed you earlier that Harry Smith is using to basically write on a whiteboard on the virtual screen as he was teaching, the use of online assessments rather than paper assessments. These are all things that I think we can use to really improve the quality of the education we provide our students. What I will say is that the experiences that we've developed in virtual engagement and education with students remotely allows us to take our educational programs and access student populations that might not be able to come to campus. So in parts of the world where students may not be able to come to Illinois Tech for their education, we're going to be well positioned to provide that same education remotely to them and that opportunity to have that type of education. So I do see that having an impact there.
And actually, kind of continuing, Peter has a question. Aside from COVID-19, what are the unique challenges of teaching undergraduate engineering students today?
Hey, Peter, it's nice to see you. So this is a great question because I think the needs of the global workforce of tomorrow are rapidly changing. So I think one of the challenges that we have in training undergraduate students is to have enough flexibility and dynamic nature of our degree programs to help adapt to the changing workforce needs and the needs of technology driven innovation and the like. And so I think, gone are the days of very rigid degree programs that, where the pathway is virtually defined when you enter through the door. And I think incoming right now, even both at the undergraduate and graduate levels, is the opportunity to take your educational experience and carve it out to be individualized, right? In a sense, a bit plug and play based on one's interests. The other challenge that I see in training undergraduate students is we really need to make sure that we're building the soft skills that allow them to compete and be successful in environments that rely on teamwork, collaboration, and the like. And so, I think there are aspects of Illinois Tech's approach to education that position us well in that regard. The iPros program is a great example of that. But I think that's one area that we should always be mindful that we have to cultivate those skills in addition to the technical aspects of their education.
Of course. Well, we are just about out of time. That was fantastic. Thank you so much. For everyone attending, Ken has included his email, kenneth.christensen@iat.edu in the chat box if you have any further questions. Thank you all so much for attending. Just a reminder, our next Alumni University will be with Miriam from the Kaplan Institute. That will be on March 30th. It's at a different time. It will be from 4 to 5 p.m. So a little bit earlier than some of our other presentations, but we hope you all can join us then. And thank you so much, Ken. This has been fantastic.
Thanks very much for the opportunity. It's nice to talk with all of you. And as Kristen said, I put my email in the chat box. I'd love to hear from you and hear your perspectives. Thanks for the opportunity.
Thank you.